Hi everyone. In this unit 2 of Python, we're going to learn about decision structure. So mostly we'll be learning what's the Python decision structures and then what are the common operators we can use to facilitate this type of decision structure. So in a real world, we don't just say write instructions and then have those instructions running one after another. It's like a sequential set of instructions for the computer to run. Instead, we may have some, conditions to control certain instruction will be running when certain condition is met. For example, like if I'm hungry, then I will eat, right? So this I am hungry, that is the condition which will activate this behavior of eating. If today is Monday, then I will go to work, right? Monday being the condition. And if that is the case, then I will go to work. If I'm tired, then I will go to sleep, right? So being tired, that is like the condition. And the action associated with that is to go to sleep, right? So this is in real world, we have those different scenarios. So in programming, how do we represent this kind of structure? We're going to use control structures to help us do that. So control structures or control statements are used to control the flow of execution based upon conditions or repeated actions. So there are generally two main structures in any kind of language, actually. One is called branching, and the other is called looping. And in this particular unit, we're going to look at branching. So branching is based upon conditional statements, where we're going to execute a suite of code only if certain condition is true. If it's not true, then we're going to run something else. Okay, so the keywords that are used in Python for this implementation includes if, else, and the last one is a combination of else if. Okay, ELIF, else if. So let's start looking at if statement. So this is saying if certain expression is true, semicolon, uh, we'll have a bunch of expression true suite. So this suite is actually could be a block of code. It's not just one statement. It could be a block of code, several instructions, single or multiple statements. So if we take a look at the example on the right, we first of all assign x to be 10, and we say if the condition, the expression is that x is greater than 0, okay? And then we use the semicolon. We're going to print positive, okay? If it's a value greater than 0, we're going to say it's positive, and then print thank you. So here, how do I know which statements belong to this expression true suite? We will need to use indentation to clearly mark that. So after this semicolon, all the statements that has an indentation will belong to this expression suite. So in this case, it's going to exactly print out positive, thank you. So adding one more step, the else statement. Else statement basically is saying, okay, if the expression is false, what do we do? Okay, so that belongs to this else suite. So like in this example, if x is greater than 0, we print positive and thank you. Else, else will be the opposite of x greater than 0. That means x is less than 0 or x is equal to 0. Or when we combine that, we can say x when x is less than equal to 0. That will be meeting the else condition. We're going to print x is 0 or negative and print OK. Okay, and remember these two, if we want to print both of them out, they need to have proper indentation. So that identify the block of codes that belong to this else statement. So now one more keyword, which is the else if. So what if I want to define more conditions? It's not just zero or one, it could be multiple conditions. So in that case, we're going to adding else if. So this is saying if expression one is true, we're going to run this. Else, if expression two is true, we're going to run the else if switch. And in the last, if none of them are true, so we're going to run the else switch. So updating our previous example, we initialize x to be negative 10. If x is greater than 0, we print positive, thank you. Else if x is exactly 0. So here we're using x double equals. We use this double equals to representing we are comparing, we're not making an assignment. We're comparing x with 0. If this is evaluated to be true, that means x is 0. We're going to print x is 0 and print wow. Else, that means this is false. The second condition is also false. So we're going to print out negative and by. Okay, so now we are adding one more conditions. And as a matter of fact, you can actually add as many else if as you want. Okay, to just to represent all those different kinds of conditions. So not only we can use just if, and else, we can also nest those if statement inside another if or else statement. Okay, so like here, we say if GPA is greater than equal to 3.5, uh, we're going to apply to work at top level company. Else, okay, else means GPA is less than 3.5. And then we're going to continue to break it into two more conditions. If GPA is greater than 3.0 and but it's less than 3.5, we're going to apply at median level. Else, that means GPA is less than equal to 3.5. So we apply for work at low level company. Okay, so this particular, the second if else, that is like a if block, right? And this if block served as the whole block for this else statement. So we say this if is embedded inside the outer if else statement. So sometimes when we write a lot of if else, it may be confusing. Which one are we, I mean, which one do they pair with each other? Okay, so this is called the dangling else problem. Okay, it occurs when nested if statements have an ambiguous or unclear else clause. So let's take a look at this pseudocode here. So we say if condition one is met, and then embedded inside if condition two is met, we're going to do something, right? Because based upon the indentation, that's how we read it. Else, do something else. So for this else statement, what do you think? Does this else pairs with the first if or this second if? So in some languages other than Python, this is going to cause ambiguity because we don't know, okay, which one this could be pairing with based upon that language's feature. But in Python, how this is done is through the indentation. We're going to identify that. Okay, so let's take a look at this following example. If code and if windy, print movie. So if it's cold and windy, we're just going to watch movie. Else, this else has the same indentation as this second if. So this else pairs with this second if. So else print beach. So that means if it's cold but not windy, we're going to go to beach. And in the last statement, we're just going to print have fun. No matter what, we're having fun. Okay. So in this second case, if cold and windy, watch movie. Else, But this else has the same indentation as the first if statement. So this else actually pairs with the first if statement. Else print beach. Okay, so if it's not cold, then we go to beach. If it's cold and windy, we watch movie. Okay, and then we'll have fun. Okay, so when you write Python code, you just need to make sure for all the block of code, all the statements, could be single or multiple statements, that you want the if statement to execute, then you're going to have them in the same with the same indentation to represent it. Also, a common mistake is that don't forget about this semicolon. Okay, so we talked about briefly those expression. What can we use for expression? Okay, we usually we usually use this relational operator or comparison operators when we are dealing with if-else statement. Okay, so this is to compare two values. Relational operation, they're going to return Boolean values, either true or false. Boolean value only has those two values, right? And the first letter has to be capitalized, okay, to use the value. So some of the common relational operators includes if we use double equal, this is to check whether the left value here equals to the right value. So it's going to return true if the two values are equal. Um, if we use this exclamation plus equal sign, this means not equal to. And then greater than, less than. For greater than equal to, we use those two symbols, less than equal to. Okay, so these are the very common relational operators. So here are some of the example. We say we're assigning x to be 10, y to be 5, okay? And we're going to simply just print x greater than y. What do you think? What will be printed out here? Because 10 is greater than 5, so this is going to print out true. And then the second one, print x double equals to y. So this is checking whether x and y, they are equal. In our case, this is going to print out false. So similarly, this is going to print out true because x does not equal to y. X less than equal to 10. 10 is less than equal to 10. So this last one will print true. So in addition to those comparison operators, we can also have logical operators to combine multiple conditions. So in Python, there are generally three logical operators, and, or, not. Okay, like in this case, it kind of match with our natural language, right? So like in this case, we want to check if age is, I mean, we have an age and whether this person has an ID or not. So if age entered here is greater than equal to 18 and this person has ID, then we're going to print you may enter. So this will only be printed if both conditions are true, right? And basically means both conditions need to be true. So true and true implies true. If one of them, any one of them is false, like true and false will be false. False and true will be false. If both of them are false, of course, the end result will be false. Okay, so this is like the basic rule of thumb when you are doing and. Okay, then or will actually it's slightly different, or will return true if at least one condition is met. Okay, one condition is true. So for example, like here, we're assigning that the day is Saturday. This if statement basically says if the day entered is Saturday or Sunday, then we're going to print it is the weekend. So no matter it's Saturday or Sunday, like in this case, we're going to print out this is true. I mean, this is true, evaluate to be true, and then we'll be printing that out. So this is the truth rule for or, right? So you can see as long as one of them is true, then the or result is true. If both of them are false, the or result will still be false, right? So if it's not Saturday or not Sunday, then we're not going to print that out. And the last one is the not keyword. Not basically will change true into false and false into true. Okay, just reverse the Boolean value. So here we're setting, this is kind of like a Boolean flag, is logged in equals to false. So if the person is logged in, so this is saying not false. The negation of false is basically true. So this is saying, please log in if you're not logged in. Okay, so not true turning into false, not false turning into true. So with the comparison operators and logical operators, we can make our condition to be very complex to represent the different types of logic that we want to represent in the real world. Okay, so when we have multiple relation expression and those comparison and logical expression, I mean logical operators, those relational expression, they will be evaluated first, and then the Boolean operators. Okay, uh, and also Python is going to stop evaluating expression as soon as we can determine the result. Okay, so we can kind of ignore the rest if we know for sure. So, like in this particular case, this is saying temperature is 75. If temperature is greater than equal to 60 and temperature is less than equal to 85, we're going to print comfortable temperature. So both need to be true, both conditions, because it's and, right? So first of all, we're going to check if 75 is greater than 60. This is true. And then 75 is less than equal to 85. This is true. So true and true, we cannot stop evaluating because this is an and situation. So let's practice those following example, okay, and try to find out the true false value, okay. So this first here, print 2 is less than 4 and 2 equals to 4. So this first part is evaluated to be true, but the second part is evaluated to be false, so the result will be false. 2 greater than 4. So when Python is evaluating this first condition is already false. So in that sense, because this is a or, so we're still going to look at if the second one is true or false. Okay. Even though the first one is false, the second one, 2 is less than 4, that is true. So false or true, the result is true. Print not 6.2 less than 6. So first of all, we'll be doing the comparison, right? So 6.2 is not less than equal to 6. So this is false. So the negation of that will be true. Okay. And this next print, we'll be printing 4 less than 2, which is false. So keep evaluating. Or 6 is greater than 4. This is true. But the last one is and, right? Okay. 3 is less than 5. This is true. So this is like true and true, false or true. So this is still true. Okay. And we can actually use those comparison operators like in a chain. So 3 is less than 4, less than 5, and less than 5. So this is true. Okay. Oh, so finally, this print statement, the second to last, If 3, so Python will be evaluating 3 is less than 5. And then the next one is or. So this doesn't even need to be evaluated because this is true already. So no matter whether this is true or false, the ending result will be true. Okay, so you can work on this last one. All right, so if we combine everything together and then try to work on a simple scenario. So we have student qualifies for a scholarship if the student's GPA is at least 3.5, and then they have completed at least 30 credit units. And if GPA is below 2.0, we're going to have like academic warning. So we can write the following code for checking the eligibility for scholarship. So first of all, we want the user to enter what's the GPA, right? We use the input function. And we're going to convert that into a floating point value. And then we're also going to ask the user to enter the completed credits, convert that into integer because credits supposed to be integer, right? So then we're going into this if-else statement. If GPA is less than 2, print academic warning. Else, it's greater than equal to 2, right? So then we're going to have those situations. If GPA is greater than 3.5 and, right, so because this is and, number of units is greater than equal to 30, then eligible for a scholarship. Else, no matter it's either GPA less than 3.5 or not enough credits, right? Then we're just going to print not eligible for scholarship. Okay, so this is a if-else statement embedded inside another if-else statement. Okay, and remember, we are using the very clear indentation to identify which statement belong to which block. All right, so you can work on this following exercise by yourself, okay, just to practice this if-else statement. Thank you.